All right, it's time. Welcome back. Hope you had a nice long weekend. We do have homework for today, so check it out. On Friday will be our first big test. A little something to look forward to. It's going to cover everything up until, but not including regular expressions, what we just started last time. So actually, I just sort of by way of preparing for the test, I don't have a big bunch of review stuff or whatever, but I at least wrote up a sort of a list of topics, and then we could talk about anything that you like, or else we could just go on with the rest of, talk about some regular expressions some more. But anyway, here is what I consider to be the test topics. Basically just DFA and NFA. So for DFAs, we had, these are types of questions that you should expect to see. Something like, make a DFA for this language. A to the N, B to the M, something like that. I give you a language, you make a DFA which accepts that language. Or the other way around, sort of give the language of this DFA. I might show you the picture and you have to tell me what the language is. There is also, related to that, prove that this DFA accepts this language. Those are the induction proofs that are, I would say you have to know how to do those kinds of proofs, but in my opinion, they're not that hard to do if you can remember all of the typical setup and ingredients for doing those proofs. I hope that you feel the same way. Then we had just sort of very basic things about the formal description. This is very easy if you remember what I'm talking about. So I could show you a DFA and then say, tell me what the formal description of this DFA is. That's the 5 tuple where you write out what the function is, the delta. And then you could also go the other way around. If I show you such a formal description, I might ask you to draw the picture of the DFA. And then last type of question for DFAs, something like give a DFA for this union or intersection or complement. The union and intersection are that's what we call the product construction, where you make a new DFA which is made up of pairs from the original ones, and you draw the arrows in the appropriate ways. The complement construction is even easier than that. That's the one where if you have a given DFA and you want a DFA for the complement, you just use the same diagram, but you flip-flop all the accepting and rejecting states. All right. Those, I think, were pretty much all the different types of questions that you might encounter concerning DFAs. And then NFAs. So I will say for NFA, basically these first 4 things exactly again, right? Make an NFA for a particular language, or maybe I show you an NFA and say, what is the language of this NFA? Or maybe prove that this NFA accepts this or that. Those are, in my opinion, slightly harder than the DFA ones, because you have to remember the rule about the delta star is weirder. And then there's also the formal description of NFAs. We did not do the unions and intersections business for NFAs, although we did talk about, and this is another important thing, convert NFA to DFA, and that is using what we call the subset construction, and we did that, I think, last time or maybe the time before. And that is about it, in my opinion. Anybody feel like I'm leaving something out? This, I think, is pretty much, every question on the test should be somehow related to these topics. Anybody want to talk about any of these? We could go over any of these if anyone is unclear. Yeah?
You think you could go over proving an NFA?
Sure. Prove that this NFA accepts this or that language. So I'm going to try to, yes. It's maybe the hardest one for me to invent an example on the fly. It turns out that some of these are actually very hard to prove, and they require variations on the standard proof that I didn't really want to get into the details of. And so, well, I'll just try and invent something simple, and hopefully it'll be okay. I really don't know how this is going to go, but we'll try it out. And I also don't know, I don't want to invent an example that's just the same as something on the homework or the same as something that we've already talked about. I also, because the NFA ones are a little harder, I decided that I was going to do ones that don't require you to like prove a separate lemma. And I don't actually know if this is true of this one, but let's just see how this goes. I'll put some random stuff at the bottom. That stuff at the bottom of the diagram probably won't have to do with anything because there's no accepting states down there, but we'll see what happens. All right. So let's see if we can prove the language of this NFA. I hope that this works out okay. I'm not totally sure what'll happen, but we'll try it out. First of all, can someone say, like, what is the language of this NFA here? This accepts, if I were to write it as a formula, A's and B's somehow? What do you think? You should immediately recognize that like this stuff down here isn't really going to matter at all because you can't get to an accepting state by going down there. What do you think? Yeah?
Is it B to the N A?
B to the N A, I agree. Yeah, the only way to be accepted is if you go here, first of all. Then you could do a bunch of B's if you like, and then do an A, and that will be accepted. So B to the N A. I agree. That's the language of this machine. So I'd like to prove that this is accepted. We should give some names to some of the states because you need to refer to the states by name in your proof. The one at the bottom doesn't matter, but I will call these other ones, let's call them just ST and U. All right. And so what I want to say formally speaking is that delta star of S B to the N A includes U, right? You could say equals the set containing U, but I think for the sake of doing the induction, this might be more convenient, although probably it's not going to matter. Like I said, the details on these can be a little bit touchy, and I'm a little unsure of myself just because I'm making this up on the fly. I think this is going to be fine, though. All right, so we got to do the induction. So I'm going to proof by induction on N. All right, and we begin, as always, with the base case, which in this example and in most examples is easy. The base case is n equals 0. I want to show that delta star S B to the 0A contains U as an element. And how do we show that? Well, delta star of S B to the 0A is the same as delta star of S and A. And what is that? Delta star of S and A, just looking at the diagram. The only way to do A from, actually, I didn't expect this, but I think I am going to have to refer to this one at the bottom. Let's call this other state V down there, because delta star of S and A is, I believe, the set of U and V, right? That means if I start in state S and try to read the string A, where could I end up? I could go down here to V, or I could also go epsilon followed by A and end up in U. All right, so after doing S and A, where you can end up is the set U, comma V. Now, I'm trying to show that this contains U as an element, but it does. So I can just say this contains U. And so this step is shewn, right? How am I doing so far? All right, that was just the base case. It better be easy. Slightly weird because you get this other state in there. No problem. All right. Okay, how about the other case? Sorry, I'm still getting nervous here. We'll see what happens. I think it'll be fine. I don't know. The induction case. All right, so we begin with the induction hypothesis. I'm going to say assume delta star S comma b to the k a contains u as an element, and then I want to show delta star of S b to the k plus 1 followed by a contains u as an element. All right. And as usual, you are going to sort of break apart this string, b to the k plus 1a, I think of as b first, followed by b to the ka, right? And you have to do this somewhat weird thing here. And as a bit of a, I think that this will work out okay. So maybe I'll refresh our memory about the strange rule about delta stars that we're going to use. I'm going to try and write it up here. I'll write it up here in red. It says something like if delta star of S and X contains T, then delta star of S and XY contains as a subset delta star of T and Y. And this is a weird rule that unfortunately you just have to remember. It's not so hard if, I don't have this formula memorized. I was in the back of my mind trying to remember what all of this business means. But if you start and you do X first, you end up somewhere. Then where you can go from there by doing Y is a subset of where you could get starting from the original start and doing X followed by Y. It's a little complicated to remember this property. But anyway, I'm going to use that down there where my X and Y are going to be B and B to the K A. So that's my X, that's my Y. And what's playing the role of S and T up there are S is S, and this U is playing the role of T. That's the idea, I think. Oh, now I'm not sure I like this anymore. B. Yeah, I now realize that I don't like this anymore because this U is not appropriate to play the role of T here. T is where you go. I actually want T. I was afraid this might happen. I think the proper way to do this one is using a lemma. Sorry, where the lemma says, I'm trying to think if I can write this without just erasing everything. Yeah. I don't think I can say this in a better way. Sorry, it has to be written differently. How about this? Maybe. So the moral of the story is I would not ask you to do this on the test because it's not hard per se, but it requires a very slightly different. It's a lemma, really, is what is required here. I would say instead of that, it's better to prove a lemma here that says something like delta star of S and B to the N contains T. That we would prove by induction. Can we just do that? Sorry. Let's prove. So this stuff here, I didn't write anything wrong. It's just that the induction is not appropriate to make the proof work. this will be able to prove using the induction better. So I'm going to prove that this is my lemma. Delta star of S and B to the N contains T. And then we can, once you know that that contains T, then if you follow that by A, it will go to U. And that will be no problem. So here, I would say the base case, here's my proof. Sorry about this. Well, you can tell I was concerned something like that would happen. Delta star of S and B to the 0. This is the same as delta star of S in the empty string. And that actually equals S comma T. If you start in state S and read the empty string, you can either just stay in S, having read nothing, or you can follow the epsilon arrow and go over to T. And that contains T as an element, which is what we need to show for the base case. All right? And then the induction case. We assume delta star of S and B to the K contains T, and I want to prove delta star of S and B to the K plus 1 contains T. And now we can do this. This will work out much nicer. I write this as B times B to the K, and I use this and this as my X and Y. And I can say something like, since delta star of S and B, this is delta star of S and like the X contains T. I'm following the formulas in red that I wrote way up there. I hope you can still see them. I can see them in my mind, in my heart, written in my flesh and bone. I can see those formulas. All right, since this is in T, that means, or since T is an element of delta star S and B, then delta star of S and B, B to the K, contains delta star of T and B to the K. And by the induction hypothesis, this is not what I wanted. I'm still not proving the correct lemma. The correct lemma, sorry, can I just scribble here? Needs T's here. This induction is very touchy, and this is why I said, like when I write the problem for you on the test, I will set it up so that you're not going to make these simple little mistakes. You have to be very careful about how exactly you structure your induction argument. All of these S's, in order for the induction to work, they need to be T's. Sorry about that. Okay, now this is no longer very interesting. It's just T, all T's. T's, 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 T's. Okay, now we can use the induction hypothesis, all right? It now says T and B to the K, which contains T. I'm all thicked up now, all right? So the lemma is proved. We okay now? All right, and using that lemma, we don't have to do any more inductions. It's just a matter of patching together what we have from the lemma. So now our real theorem to be proven is that delta star of S and B to the NA contains U, right? I break up B to the NA as B to the N followed by A, right? This I'm going to, break up in sort of X's and Y's. This is the X part, this is the Y part. And we know that delta star of S and B to the N, okay, this is equal to, well, S, starting in S, we can do epsilon followed by B to the N. So this actually contains, this is another slightly weird step, which I would not necessarily expect you to go through a slightly weird argument like this on the test. But here, because there's an epsilon arrow from S to T, It means all the states you can get to from S and b to the n are contained in the states you can get to from t and b to the n. That's because there's an epsilon arrow from S to t. So before doing anything from S, you can do the epsilon first and do the same thing from t, all right? But anyway, this, I'm sorry, there should be a, well, no, that's okay. Since this, this contains t by the lemma, right? That's what the lemma said, delta star of t, b to the n contains t. Then we can do the old xy thing. So since delta star of s and b to the n contains t, then delta star of s b to the n a is a superset, contains delta star of t and a. And that is u, or it contains u at least. And that's the end. All right, are you happy you asked this question? Sorry, I was unprepared to make up an example like this, as you can see. The induction proofs here are touchy in a way that I don't intend for you to have to handle on the test, but this is something I didn't mention, but at least for these, the DFA ones are quite a bit easier. For the NFA ones, basically I'm only gonna give you easy ones, where by easy I mean you don't have to do any really weird lemmas like this. This is not exceptionally weird, but it does require that you be kind of smart about choosing precisely the correct lemma to prove, and it's not always obvious what that is. All right. Thank you for the question. Any other examples? I'll scroll back up here. Any other things to go over? There is some amount of, I hope you feel like this, there will be a mixture of like proving things. I'm probably not going to ask you to do more than one of these proofs. And then also kind of remembering these various nuts and bolts sort of constructions here, where you start with a DFA and you do this and that to it to get another DFA or NFA. All right. Yes?
Could you do an example of converting an NFA to a DFA?
Yes. I would be happy to do an example. Convert an NFA to a DFA. How about this one right here? Can we try this one? Just since it's already there. And these ones will not require any kind of, I'm fairly confident that nothing weird is going to happen when we try to do this one. All right? The only bad thing that could happen is the DFA that you end up with ends up being super big. And that, I suppose, in theory, that could happen with this one. We have 4 original states, and every state that I'm going to create is a subset of these. In theory, there could be up to 16 possible subsets. It'd be 2 to the 4. But I don't think that's really going to happen in this case. So let's try convert to NFA, DFA. This already is an NFA. Convert to DFA. All right, there's ones on the homework like this, the homework that's due today. So remember, this is what we call the subset construction. Can anybody, maybe we'll try and do this one together. What should the state that I start off in be? Typically, you would just use S, although it's not exactly just S. Anyone remember how do you invent the starting state in the subset machine? Yeah? It is S and T, yeah. The starting state is always the original NFA starting state together with any other states reachable by epsilon from that state. So I begin in a state labeled S and T. All right? That's because this consists of the original starting state together with all other states reachable by epsilon. Okay, and now I am just going to draw arrows. I should have because this is going to be a DFA down here, I need an A arrow and a B arrow. So my A arrow from S and T, it means if I do A, where are all the states that I could end up in if I start in S and T and then do A? So from S, I could do A here and get to V. From T, I could do A here and get to U. And I think that's it. So from S or T, if I do A, I can end in U or V. All right, so my A arrow shall go UV like that. All right. What about the B arrow? Again, you look in states S and T. Where could you possibly end up starting from either of those and doing a B? I think it's just T, right? You have to be careful about the epsilons. So when I say do a B, I mean you could possibly do epsilon first and then B, or perhaps B followed by epsilon. None of that can happen though. It's just going to be T. So the B arrow here, I don't know how this diagram is going to look, but I do it like that. All right? And proceed from there. How about from U and V? Anybody want to say? Where's the A arrow? From U and U comma V? Do a A. Where can it go? Nowhere is the answer. Yeah. What's your interpretation of that? What? Yeah, there is a state down here labeled with the empty set, and that's where that one goes. That's A, not B. The A actually goes the B actually goes somewhere. But from U and V, if you do A, it can't go anywhere, and so that's an empty set state. The empty set state always gets one of these when you're doing these problems. That's because if you start nowhere and do A, you end nowhere. So that's, and same with a B. Okay, from the UV, when I do B, I think the only way, starting in UV, the only way to go if you do a B is just to V. So I'm going to put I hope I'm not going to have to cross the arrows, but just a B goes out like that. All right. In state V, I believe A goes nowhere, so that's down to the empty set state, and B goes back to itself. So that's easy enough. And then the T state. The T state, if I do a B, it should go back to itself. If I do an A, it should go over to U. So I think this is just one more state on this diagram. Like that. Sorry, I'm trying to keep it all visible here. And then the U has no outgoing arrows. This goes to the empty set, A comma B. There you go. I think this is the whole diagram. Anybody disagree? What about the accepting states? Anybody remember how to handle that? Which ones are accepting downstairs? Yeah? Yeah, anything with a U in it. It's any of these states which contain any of the original accepting states. Since U is the only accepting state originally, it's down here, anything with a U in it, which would be that one and that one. Yeah, great. The empty set state is never accepting in any example. It's always like a permanent failure state. That's that. Any questions? I had one more thing just to remind everybody. This language, remember we said this is the language is B to the NA, right? One thing to notice is this is not the simplest possible DFA for that language. It's actually easier to make, this has 6 different states. You can make a DFA for this language with fewer states. Here's just a little terminology I want to make sure everybody remembers because you may see it on the test. Is this a regular language or not? Anybody remember what that means? This is an important piece of terminology that I hope everybody remembers what it means. Show me the thumbs. Is it regular? Not regular. I see some thumbs up. I see some tentative, some sort of face scratching. The answer is yes, it is regular. Anybody actually remember what that means? Yeah? What do you say?
Isn't it any language that you can make into a DFA?
Yeah, right. Any language of a DFA is called regular. So it's definitely regular. And since we know now that the languages of NFAs are the same as languages of DFAs, because you can convert from one to the other, if you ever see an NFA for anything or a DFA for anything, that's automatically a regular language, because that's what regular means. It means it is the language of some NFA, DFA. Basically, every language that we've ever talked about has been a regular language. We're going to move on soon enough to non-regular languages, but anything which is the language of a DFA or NFA is automatically regular. That's what it means. All right, great. I think maybe that'll do for review. I did want to talk a little bit more about regular expressions today. But if you have more questions about the test, more things come up, feel free to send me an email. I'd be happy to try and help out that way. I hope the test goes great for everybody. It's going to take up the whole class time. It'll be just like the quizzes, only longer. Right? Excellent. Great. Let's talk some more about regular expressions. Regular expressions. Regex. I don't know how people say that. All right, regular expressions. This is a third way to describe languages. We've had NFAs and DFAs. Regular expressions is another way to describe languages, but it doesn't look like a machine with states at all, but it looks more like something like A, B star, A, B plus B. Something like that. That's a regular expression that I just made up. And this refers to a particular language which this sort of accepts or rejects various strings. Although, like I said last time, the terminology that we use, we say this one matches. Maybe I'll just say this one matches strings of the form, just because I know how to read regular expressions. And we did talk about the basics last time. It matches strings of the form A, B to the N, A, B, or A, B. Let's just try and talk through again how to read one of these regular expressions. You just have to understand what the various operations means. And the operations are the star, the plus, the parentheses, and also sort of what does it mean when you just write one thing next to another thing. So I will refresh our memory. The plus means or. This is easy enough. The star means, I would say, something like iteration, or you could say repetition, although it's not precisely repetition in the usual sense. I would say iteration 0 or more times. And then the parentheses just mean, groupings like in ordinary mathematics. And what we call juxtaposition, when you just write one thing next to another, that means concatenation of strings. So something like, I don't know how to write that. I will just say concatenation. I gotta spell it right. Concatenation means what it is. Maybe I didn't have to write this. Concatenation. I mean, when you see things written next to each other, like this A next to a B, it means A next to a B. That's what that means, all right? The only thing that's a little weird is, what does this A on the outside of these parentheses means? It means A first, followed by this or this. So you have to read the parentheses properly, but that's what this means. It means first I have an A, and the A is followed by either this or this, because that's what the plus means. The plus means or, all right? And that's why I hope everybody can see now why I said this is what this regular expression matches. It must start with A. It could be A followed by B star AB, which is that. The star I translated into a B to the N because the star just indicates repetitions of B 0 or more times. So that's one way, or it could be A first followed by B, which is this, all right? You can tell, actually, there is some kind of a distributive property for regular expressions, like from here. If you have something like A times X plus Y, you can actually sort of distribute the A. This really is the same as AX plus AY, right? As regular expressions, what this means is first I see A followed by either X or Y. And what this means is first A followed by X or first A followed by Y. So they really are the same Even though this is like a familiar looking property of numbers, I'm saying something completely different from the distributive property for numbers, but there is a distributive property. And there are other kinds of algebra properties for regular expressions that we're not really going to get into, but these things are true of regular expressions. All right. What I wanted to do here is just to talk about, I just want to do a bunch of examples for 15 minutes or so. For example, how about what strings are matched by, how about a plus b squared star? And here's where the fact that I said the star kind of means repetition, but I would rather say iteration than the word repetition. What the star means is, it means you can sort of go through this thing on the inside 0 or more times. But since the inside here has this or in it, when you're doing the star, you don't have to choose the same option every time. So it's not precisely repeating things on the inside here, but it is sort of, I think of it more as running through this regular expression over and over again. But since that involves a or, you can choose either one or the other. All right. So what strings are matched by this? I would say it matches, it matches A, because that is if you're doing the star but you only run through once and you just pick A, right? Or it could match B squared. B squared, that is if you do the star once but you choose B squared. Or it could match something like A, B squared, A. That would be if you go through the star 3 times. The first time you choose the A, the next time you choose the B squared, then the third time you choose the A, and so on. Right? Really, it's any string which uses A's and B's where all the B's occur in blocks of 2, right? You have to have 2 B's at a time, or I suppose an even number of B's at a time. You can never have like a B cubed in there, all right? Any combination of A's and B squareds. And this also matches the empty string. Maybe I'll put that in as a special case, because you're always, whenever you see the star means 0 or more times. So you can just pick the empty string. All right. Great. Let's just do a bunch more examples here. We've got time here. How about, so you're going to see some homework problems of this type. Make a regular expression for this language. How about a to the n b a? Anyone think you can do it? A regular expression which makes a to the n b a. Not terribly complicated, this one. I want to see something with A's and B's, stars and pluses. Although just between you and me, I don't think you need a plus for this one. Any ideas? Yeah?
A star BA.
A star BA, yeah. Can you just change all the N's to stars? The answer is kinda. This is a very simple one, and so yeah, that ends up being true. Some repetition of A's, followed by B, followed by A. Yeah, that's all there is to it. Great. How about, let's make it a little more interesting. How about a to the n BA, where n is greater than or equal to 1? So this is a little inconvenient to express with our regular expressions. The star always means 0 or more times. So anybody, you have to have a somewhat cute idea. Can we somehow express that, even though the star always allows for 0? Anyone got an idea here? I want to somehow make it, I mean, it's basically like this, but you have to make it so that it's like forced that there's at least one A in there, and you never skip the first A, something like that. Anyone got an idea? Yeah?
Is it A star B A?
Yeah, I like that. A star, B, A. Yeah, excellent. So he's doing what I said. You're going to use the star. The star means 0 or more times, but to force it to have at least 1, you just put that 1 in there, right? So it's got to have 1 followed by some more if you want. Yeah, great. Okay, how about, here's something a little trickier. A to the n, B, A, where n is less than 3. So this time there's like an upper limit to the amount of A's there. This requires yet another cute trick. Any ideas here? Anybody feeling cute? I know, sometimes when I feel cute, I don't want to say it out loud. Yeah, you feeling cute?
Would you just like AABA or ABA? Could you just or it?
Yeah. Or it, he says. Yeah, so there, one realization, which you probably agree when I say it, you cannot use a star here because the star always means 0 or more times. Like if you're going to use the star, that immediately gets you like infinitely many options, which you don't want in this case. So instead of using the star, there's only like 3 possibilities for n, and you want to allow n being 0, 1, or 2, and that's it. So you just write those out with ors. Now what he said, I'm going to write something slightly different from what he said, but it's the same. I'm going to say empty string or AA followed by BA, right? So this means that first part there, I'm just choosing, it's either nothing or 1A or 2 A's. And then that stuff is followed by BA. Now what he said before is also is not wrong. To me, I prefer writing the way that I just did, but you could have also written just, I think this is what he originally said, BA or ABA or AABA. Right? Those are equivalent, right? Excellent, great. How about, okay, here's a back to something simple. XB, where X is in AB star. Right, that is any string which ends in a B. This is a common pattern that you're going to see often. When you see basically an X, which could be anything, the way you write that in regular expressions is this, A plus B star. If you think about it this way, when you do A or B star, the iteration through the star means this could give you any possible string involving A's or B's. You know, if you want to get A, B, B, A, you could go, first time through you choose the A, then you choose the B, then you choose the B, then you choose the A. So when you see A plus B star, that means it could be anything. That's the X part, and then followed by B. So that's how I would write this regular expression. A plus B star B, like that. All right, something like, how about, here's another way to say it. Something like X such that X starts with A and ends with BA. Anyone want to give that as a regular expression? Starts with A, then it's got some stuff in the middle, then ends with BA. What do you say? Yeah?
A, and then in parentheses, A plus B, then star, and then end with BA.
Yeah, great. Yeah. So this says we begin with the A first, and then this can be anything, and then BA at the end. Yeah, excellent. Great. This, you know, as you see this more and more, you begin to get a feel for what regular expressions generally look like. How about another one? I got one more, and then I had some for you to try. Maybe we could try a few. I know we got to go soon. How about X such that X contains BA somewhere? Not necessarily at the beginning or end, but somewhere in the middle it has BA. Any thoughts? Yeah?
In parentheses, A or B star, BA, and then A or B star again.
Yeah, great. A plus B star, that means it could be anything, and then BA, and then could be anything after, right? I like this. BA has to be in there somewhere. It can have any other stuff at the beginning, any other stuff before it, any other stuff after it. Yeah?
Could in the parentheses those be empty strings as well? Or?
Yes, yeah. Because the star, remember the star always means iterations 0 or more times.
Oh, okay.
Yeah, so those, if you want, they could just be empty strings. Yeah, great. How about, I'll give you a few minutes. See if you can think of regular expressions. How about x contains 3 at least 3 A's, like anywhere in it, and then also x contains exactly 3 A's. See what you think. I'll give you until 1:49, I guess. I'm gonna walk around quickly. I would say the previous one is like anything, meaning this one, you want like, it could be anything, but it has to have maybe it's perhaps surrounded by some other stuff. No. This looks good. Anything. This. So change it to allow. Yeah. Excellent. Yeah. Get anywhere? Yeah, like that. Yeah. Uh-huh. Something like something like these are good, but you have required don't next to each other, which is not. That's the thing about. So one thing that I would put a plus b first, because we start also, because you, here you need them all, A's, all, which is not. Second. You get anything? What should we start A's? A plus b. Oh, okay, yeah. Yeah. All right, it's time to go. Here's what I said. There are a few variations that that would work here. For this one, at least 3 A's. I want to see 3 A's in there, but then possibly just like any other random other stuff. So to me, the clearest way to write that is some kind of stuff followed by there's 1 A, followed by some other stuff. There's one more A, some other stuff. There's one last A, and then maybe some other stuff afterwards. Sorry to squeeze it all in there. This is kind of redundant, like there's probably more B's in there than I really need. But, I mean, there's probably more A's in there that I really need, but this guarantees that I have 3 A's in there together with just some other stuff, and I don't really care what else. And then exactly 3 A's means those are the only A's and everything else must be B. And so exactly 3 A's, you can just write like this. Right? There are 3 A's and the rest of it are B's in some locations. All right, that'll do. We'll do a lot more of these next time around, next week.